Hello guys, today we're going to go over 0.6 matrix operation. Now pretty much, what is a matrix? A matrix is just a rectangular array of objects or constants. An array is an accumulation or a group of objects or constants. Now normally in matrices, we have numbers. Sometimes we'll have variables, but mostly numbers for the moment. Now, a couple of things about a matrix. A matrix is composed of a series of horizontal rows and also vertical columns. The matrix is named with a capital letter, A, B, C, etc., and is always held between brackets. Each object within a matrix is called an element. Now, usually when we try to describe matrices, we use its dimensions. Pretty much it's rows and columns. The rows will always go first and the columns will always go second. For example, this matrix has 1, 2, 3 rows and 1, 2, 3, 4 columns. This would be a 3 by 4 matrix. We can have matrices that are smaller. This would be 2 by 2. We can also have matrices which are just a row. This is 1 by 4. 1 row, 4 columns. Now usually one thinks of a column as a group of objects or, bricks or whatever. Here, a single one is considered a column still, so it's 1 row and 4 columns. And that was, by the way, example 1, the dimensions of a matrix. There's a row matrix, it's just a row. There's a column matrix, it's just a column. There's a square matrix. Square matrix has the same number of rows as it has columns, 2 by 2, 3 by 3, 4 by 4, etc. There's a zero matrix, which is a matrix full of zeros. We'll see that in about 4 months. And also there's another concept of equal matrices. Equal matrices pretty much can be named differently, but everything inside them is identical. Pretty straightforward stuff. Now we're going to go into a couple of operations today, and they are very simple and straightforward. We're going to go over addition of matrices, subtraction, and scalar multiplication. Not actual multiplication, scalar multiplication, which is a bit easier. For example, let's say I have matrices. This is A, 1, -2, 5, 6, and B is -2, -3, -5, or +6. Now, one thing to note, in order to add or subtract matrices, they have to have the exact same dimensions. If they have different dimensions, they cannot be added or subtracted. This is a 2 by 2 matrix, this is a 2 by 2 matrix, I can add them. Now, when you're gonna add, it's pretty simple. A plus B, all you have to do is add the corresponding elements. 1 and -2, when I add them, I end up with -1. -2 and -5, -7. 5 and -3 gives you a 2, and 6 plus 6 is 12. So addition is pretty straightforward. You just add the corresponding elements. That's it, nothing new. And remember, they do have to have the same dimensions. Now subtraction is pretty much just like addition with a small extra. The negative is distributed within the entire matrix. So if I go A minus B, I would say 1 minus -2. Minus -2 turns it into a positive. So it'd be 1 plus 2, 3. -2 minus -5. Negative turns positive. So it'd be -2 plus 5, or the value 3. 5 minus -3 turns into +3. 5 plus 3 is 8. 6 minus 6 is 0. And that's your resultant matrix. Now again, subtraction is also pretty straightforward. Think of it like a parentheses that you are distributing you're distributing the negative sign throughout the entire matrix, just as if it were a parentheses. Now let's go over scalar multiplication, which isn't normal multiplication. We're going to go into normal multiplication in chapter 6, and that is a somewhat more complex process, not that difficult anyways. But scalar multiplication, pretty much, it's when we do, for example, 4b. And all you're doing, again, is distributing that number within the entire parentheses. 4 times -2, -8, 4 times -3, -12, 4 times -5, -20, 4 times 6, 24. It's called scalar because you're pretty much scaling the matrix by a factor of the number you're using. You can scale, you can make it smaller, multiplying by 1/2, or a proper fraction, you can make it bigger, multiplying by a number bigger than 1. That's pretty much it. So as far as matrix operations for now, in this introduction, you need to know addition, subtraction, and scalar multiplication. 2 more things before we finish off, because again, today's class is very simple. You are able to identify objects or elements within a matrix using the following method. Now, let's say, for example, I have matrix A is 1, -2, 4, 5, -6, -8, 7, 10, whatever. If I want to find a particular element, I can use the lowercase, which symbolizes an element of this matrix. So I want an element of matrix A. And just like the dimensions were rows times columns, you're going to put 2 numbers here. The first one will be the row in which the element is found. The second one will be the column in which that element is found. So for example, if I have 2, 3, this is the first row, this is the second row. So it would be this row, because it's the second row, and in the second row, I would go into the third column, meaning the element A20, it's not A23, it's A23, would be -8. So again, this isn't A23. Many students think this is a number. No, the first number symbolizes rows, the second number symbolizes columns, just like the dimensions of a matrix. Let's do another example. 1, 4. And also note, there is no comma, there is no parentheses, there isn't anything. And these numbers, if you look in the book, are smaller. They're actually subset. So it'd be 1, 4. They're smaller. They're like smaller exponents in the bottom of the variable. So again, row 1 would be the top row, column 4. 1, 2, 3, 4. You would get 7. Pretty straightforward, pretty easy. Anybody can manage these concepts. The last thing we need to go over before we finish is multi-step processes. Again, just like regular PEMDAS, for A plus B. All you would have to do is pretty much add the matrices A plus B, then scale by a factor of 4. Just like regular PEMDAS, additions come before multiplication in parentheses, or, well, no, just to clear things up, parentheses come before, and there's an addition within the parentheses, then you do multiplication. And that's pretty much it for today's class, so I will see you soon. Take care.